All right, good morning, everybody. Okay, so this morning we're going to look at something on magnetism. We're going to look at something on magnetism. So, um, or we can call it magnetic field. All right. So, what is concept of a magnet? All right. So, we're going to be looking at the following. We're going to be looking at magnetism. We're going to be looking at magnetic field. We're also going to be looking like the line of forces in a magnet, right? Then we're going to look at the characteristics of line of force. All right. Then we'll look at the clenched rule. All right. Direction of current and field. On this video, direction of current and field. Right. Then we'll also look at the clenched force rule in a magnet. Clenched force rule. Clenched force rule. Right. Then the next thing we want to look at is actually magnetic force on a moving charge. Magnetic force on a moving charge. This is where we use the concept of BIL and the like. So magnetism. So now start from the first one. So what's the concept behind magnet? That is where I want to start from. So when you talk about magnetism, we can say magnetism is a term, all right, used expression, all right, or used in the expression of a force. In a force, we use magnetism in the expression of a force, all right. We call it magnetic force, and in some cases, we call it the force of attraction. So we can define magnetism as a term used in the expression of a force. Okay, now, and we know the law of magnetism that the law of magnet is that like poles actually repels. Okay, like poles, not to not actually repels, but unlike poles, what happens is that they attract. If you're having north to south, all right, they attract. So that's the law of magnetism. Like poles, all right, repel, while what unlike poles attract. Okay, then what is magnetic field? So let's start straight away. Magnetic field, I've started now, is defined as a region or space around a magnetic or a magnet is a region or space around a magnet where the influence of a magnetic force is felt. Okay, I'll come again. A magnetic field is defined as a region or space around a magnet where the influence of a magnetic field is felt. Magnetic field is first felt. So don't forget that I said that magnetism is a term used in the description of a force. So now we're dealing with force. All right, force is part of the major factor or term we're going to consider when we're talking about a magnet. And I've explained the law of magnetism. All right, which is anytime if you have all the two magnets before, you find out that there are signs that when you bring together, what happens is that the magnet attracts itself, and there are signs that when you bring together, there seems to be like a force of repulsion. All right, that's the concept of like poles, all right, to repel, and unlike poles, and there's attraction. So that is that. So I've explained magnetism, I've explained the laws of magnetism. Then I've talked about magnetic field that is defined as a region of space around the magnet where the influence of a magnetic force is felt. Then what are lines of force? All right. When you talk about line of force, what are you actually talking about? Line of force. What does it mean? So line of force actually is defined as a line, all right, that is tangent, all right, to the direction of a force. All right, tangent to the direction of what? Of a force. Okay, then if you want to further explain that, now there are two lines of force we have in physics. All right, a magnet. There are two lines of force. Okay, we have a uniform and non-uniform line of force. All right, there are line of force that is uniform, and we have the other line of force that is non-uniform. So we can have something like this: north and south. Okay, so you have north and south in that place, and you have the direction of the field. Okay, from this region. So this is, then we have the other one that is uniform in nature, north and south. All right, so that is that. Those are the two line of force. The first line of force is a non-uniform line of force, while the second line of force is a uniform line of force. Right, you have an arrow here, arrow here. So in case you are asked to draw in a diagram, you can do this. So this is a non-uniform line of force. A line of force. This one is actually non-uniform. Then this is a uniform line of force. All right, so that is that basically. All right, now let's look at the direction of current and field. Okay, there's a relationship that exists, so you can check for corkscrew rule. All right, and then the clench rule, which talks about the finger held at a particular region. For corkscrew, if we imagine ourselves driving a corkscrew in the direction of the current, the direction of the rotation of this corkscrew is the direction of the line of force. That's what corkscrew stated. Corkscrew. Corkscrew. Right, so I'll come again, I'll state it again. Corkscrew rule says that if we imagine ourselves driving a corkscrew in the direction of the current, then the direction of rotation of the corkscrew is the direction of the lines of force. Then there is also what I call clenched screw in magnets. Clenched rule in magnets. Clenched rule. Now, what is the concept behind clenched rule? I just want to explain the theoretical background of magnetism, and we'll now start solving. So, clenched rule, is actually an alternative, all right, to corkscrew, all right, which holds for the right hand. So, first in clenched rule, the first is tightly clenched with the fingers curled. All right, the first finger is tightly clenched with the fingers curled, and the second part of clenched rule is that the thumb is straight and point away from the fingers. All right, the thumb is straight and point away from the fingers. So then now let's look at the analogy. When a straight conductor grabs the wire and the clenched right hand, so you can study all of these laws so that we will not go into much of that in a theoretical way. So you can study what clenched rules, corkscrew rules, and what clenched rules hold. But I can give you a background from this place. So for the first one in clenched rule, when the straight conductor grabs the wire with a clenched right hand pointing the thumb in the current direction, then the curled fingers give direction of the circular lines of force of the magnetic field. All right, just write those things down. I'll explain them. Then number two, for a curled conductor, hold the wire, the clenched right hand so that the fingers curl around it in the current direction. The straight thumb give direction of the magnetic field. So in the first, the thumb is in the direction of the current, all right, and the curled finger called CURLED, called finger. All right, don't forget that I said for the first, the what? Four fingers give direction of the circular lines of force. The thumb, the direction of the current. That's for the first. Then, for the second, in the right hand, the straight conductor gives the direction of the what? Or straight thumb gives direction of the magnetic field. All right, and the core fingers give direction of the current. So that is what to understand. So you can just go and find the research. Okay, what is corkscrew and what is clenched rule? Well, these are the application. Then for the magnetic force, all right, on a moving charge, which is where I want to start my teaching from. So let's look at what happened for it. Now, consider a conductor such as metal rod of length L, which is at an angle alpha to the magnetic flux of the field. So